Yeah, GCCM, it stands for Geosynthetic Cementitious Composite. That's where it started. It took them about 5 years to begin to get it commercialized. They started off again with the shelters. Part of the problem with the shelters was they lasted too long. A lot of the military applications were looking for 3 and 5 year deals, not necessarily 10, 15, 20 year products. Um, so they moved from that into
Wait, how is
erosion
that
control.
a problem? How is that a problem? Is it just
Well,
supposed to degrade? Is it just supposed to biodegrade or go away or what? I don't
Well,
understand.
the material's heavy, and after 3 or 4 years or however long the deployment was, then they had all this heavy stuff that they had to break up and haul off, and so from that standpoint, it was kind of
Too
laborious and
strong. Gotcha.
expensive to get rid of it.
Hey there, welcome to the Stormwater World podcast. Shout out to our parent company, Digital Stormwater. We're out there making an impact in stormwater one click at a time. We put more stormwater people in front of your stormwater products and services. How we get there is totally up to you. Some of the services that we offer are social media management, Google, LinkedIn, and Meta ads, SEO and content creation, website builds and updates, AI automations, consulting, and a lot more. So the question is who do you know that needs our help? If you're on YouTube, you can click on that QR code to learn more, or you can give us a call at 844-451-2534, or you can visit us at digitalstormwater.com and schedule a call with us today. I'd like to thank everybody that's been listening to this podcast. We appreciate each and every one of you. Let's get back to the episode. Hey, everybody. Welcome back to a new episode of the Stormwater World podcast. With me today is Nathan Ivy. He's the technical manager for Concrete Canvas USA. So we're going to be talking a whole lot of concrete, which is, I know, near and dear to my wife's heart as a civil PE. And I know a lot of you probably can appreciate some good concrete. But I got a little story to tell before I introduce Nathan and before we take off. He ended up, by way of the Stormwater podcast, by kind of a unique situation. Some of you that are on my LinkedIn may have seen a TikTok that I shared where some folks that did not look like they were from the U.S. were rolling concrete down a hill and then spraying it, and it was hardening, and they were saying that was good, which totally blew my mind. So I just asked a simple question, shared that video on LinkedIn and said, hey, is this a thing? Is this a thing? Do we use this anywhere in the U.S.? And that post kind of went a little crazy. And so folks got tagged from Concrete USA. So shout out to Melanie Furman. I think multiple people may have mentioned her name and she commented on it. Other people were in my DMs asking me if I needed to buy some concrete, which I was just like, I'm just looking to understand how, like, I thought, and I don't know anything about anything, as all of you who listen to this podcast know already. But I'm pretty sure, like, shouldn't there be some reinforcement? Shouldn't there be something going on here? But they were just rolling it down, and so Melanie had reached out, and then Nathan had reached out. So yes, come on the podcast. Heck yeah, let's talk about concrete canvases or concrete, and show me the way of the wizard. Explain it to me. So that's what Nathan's here to do today. So Nathan, I appreciate you taking the time to come school me on some concrete. Welcome to the podcast.
Thank you very much for having me, Ty. I'll
So
start by
before we get
go
Oh
ahead.
no, I know. Yeah, no. Before we get started, I always do this, and I apologize for interrupting. I wanted people to give a little background of yourself. So let me go ahead and do your intro
All right.
or your bio. So as I had said before, Nathan's a technical manager for Concrete Canvas USA. He has over 30 years experience in the geosynthetics industry. He held positions as technical and quality manager at both Agri and Solmax prior to joining Concrete Canvas. He has a Bachelor of Science degree in chemical engineering from Texas A&M. He is a former board member of GSI and current task group leader for ASTM. He has written articles for industry journals and is currently active in both GSI and the ASTM organizations. So there you go.
All righty.
So,
Thank you very
well,
much.
yes, sir. So go ahead, as you were saying.
So, concrete canvas is the type of GCCM. The way that it started was when our owners were in college back in the late 90s. Um, their master's project was to develop a rapidly deployable shelter system that could be used for humanitarian relief efforts, military applications, that type thing. So that's when they developed what we now call concrete canvas. It was a three-dimensional spacer fabric that's filled with concrete and has a PVC coating on the back, such that you roll it out, you peg it, you anchor it, whatever you need to do, you hydrate it, And then in about 24 hours, you've got between 70 and 80% of the ultimate compressive strength. So the way these shelters were manufactured was they had a Tyvek balloon inside. They blew up the balloon, which expanded the concrete canvas. They hydrated it. 24 hours later, they come out, take out the inside balloon, and then you've got a freestanding concrete structure that, again, could had a door on both ends, could be joined together to make different pods, again, for humanitarian efforts, military relief efforts, emergency shelters, that type thing. So that's sort of how the whole GCCM world started, was when our
That's
owners were in
cool.
college. Yeah.
That's super cool. In fact, and I think I've probably seen some videos of that too, of those structures with the balloon situation. I just need
Yes.
to put my phone down, is what it comes down to. But let's back up for just a second for myself and maybe for some of the listeners. Can you? So I know every world is full of acronyms. So can we break that acronym down? GCCM.
Yeah, GCCM, it stands for Geosynthetic Cementitious Composite Mat.
Never
ASTM
mind.
ASTM defines it as a cement-filled geotextile that hardens when hydrated. So it's pretty
Oh
much
my
a
gosh.
concrete
Well,
fill
do that.
fabric.
Okay. All right. Do it one more time. So it's GCCM stands for
Geosynthetic
Okay.
Cementitious Composite Mat.
Gotcha. Perfect. Super simple. I got that. I
Yeah,
got that
it's
locked away
rolls off the
now.
tongue.
Right. Perfect. It was super easy. All right. Cool. So so go ahead with the lineage there. I think that was where it started. So
That's where it started. It took them about 5 years to begin to get it commercialized. They started off again with the shelters. Part of the problem with the shelters was they lasted too long. A lot of the military applications were looking for 3 and 5 year deals, not necessarily 10, 15, 20-year products. Um, so they moved from that into
wait,
erosion control.
how is that a problem? How is that a problem? Is it just
Well,
supposed to degrade? Is it just supposed to biodegrade or go away or what? I don't
Well,
understand.
the material's heavy, and after 3 or 4 years or however long the deployment was, then they had all this heavy stuff that they had to break up and haul off, and so from that standpoint, it was kind of
Too
laborious
strong.
and
Gotcha.
expensive to get rid of it because it hadn't used up its lifespan. But they were done with that project in that area, and it'd be difficult to move it from place to place because now it's this giant, hard
Right.
balloon thing. So.
Makes sense. Makes sense. I got you now.
So they moved from that into the erosion control initially. There's three different thicknesses available: type 1, type 2, and type 3. One is the thinnest, the cheapest for the least severe conditions, lower flow, less abrasion, good soil or concrete remediation. Type 2 is sort of the mid grade in between the two of them. And then type 3, which they use to do the shelters, is the thickest, the heaviest, the strongest for really more extreme environments.
Cool. So how do you guys market this product? Like I've never heard of you, which doesn't mean much, but that I haven't heard of you. But like, are you guys moving through big distributors that I'd be familiar with, or are you direct selling the product, or?
So our company started off in Wales. Our owners went to graduate from Cambridge. So it started off in Europe back in 2005. From the time frame of 2010 to 2020, it was marketed in the U.S., marketed and manufactured by Milliken in Atlanta under license from our corporate office in the UK. Um, they just didn't have enough personnel and resources to really promote it as much as we thought they could. So when that agreement expired on December 31st of 20, we decided to not renew it and to instead open up what is now Concrete Canvas USA. We have a sales office in Houston where we have an office manager, an inside salesperson. We have a sales manager for the central US, for the west US, for the east US, and then I'm the technical manager covering the whole country.
Gotcha. Gotcha.
So, and we do have some distributorships. We don't have distributorships in every single state. Industrial Fabrics is our largest one here in Texas, for example.
Yep.
So we
Yep.
do have
That I've heard.
distributors
I'm
coast to
familiar with that
coast,
name. Gotcha.
just not necessarily in every state and every territory.
I gotcha. Okay. Well, you mentioned the three different types or levels for erosion control. Do you have some like, you know, uh, specifics in mind or stories that you could share on use cases that would really kind of paint the picture for our listeners on how they could
So
apply this in their programs?
Yeah, the most important thing to know about the GCCMs is ASTM D8364 was first approved in 2021 to define a GCCM, to define the types of GCCMs, and to define tests and properties that are indicative of each of those material types. It talks about, how to use thinner materials on a very firm, unyielding subgrade. It talks about how to use a type 2 material in areas where the soil may be more loose or where the flow or abrasive requirements are higher. And then T3 is again for the most severe conditions. Um, but the ASTM D8364 is the only internationally recognized standard currently for GCCMs. So just like GRI GM 13 to 17 for geomembranes, ASTM 8364 defines the types of GCCMs, the thicknesses, the compressive strength, the flexural strength, the puncture, all the physical properties that the tested material should exhibit. Um, we've seen a lot of legacy specifications, in the time period before 8364 came out, where they were trying to use a lot of existing ASTMs and sort of mold them to work with a GCCM because there aren't very many geosynthetics that start off flexible and pliable and then 24 hours later as hard as a rock. So along with 8364, we also had to develop the flexural strength test, a new compressive strength test, because the existing compressive strength tests assume that you're using the exact right water to cement ratio because you're mixing it in the back of a cement truck or in a cement factory, so it's in a well-controlled condition. But with the GCCM, like you said, you're spraying water on it from a hose, which is, worst case condition when it comes to
Yeah, I would think.
properly hydrating a concrete mix. So we had to develop new test methods, not only to define GCCMs and give them properties, but also tests that were relevant to those materials. And we continue to develop tests for the GCCM. Just last year, ASTM approved a new test method for peel strength of GCCMs. So it's a relatively new category of geosynthetics. It's only been in the US really, oh, I guess 15 years total, but as far as 8364 coming out, that's been less than 4 years now since that standard has been
Oh, okay.
available. So it's a relatively
Wow.
new category, relatively new test standards, and not everybody has heard of them before even.
So what kind of application do you have some applications you want to highlight or like or even, free call, we found out that we're basically neighbors, right? Like I live in
Right.
Orange, Texas, and you're no, in Houston, which is for those that don't know Texas, he's actually a good solid two plus hours away from me. But for us here in Texas, he's like a neighbor. Is there any applications in the ground around us? I could go check it out or
We have several applications in and around the Houston area. They were used in those for primarily for berms for storage tank facilities, Pasadena
oh,
kind of areas. Because
yeah,
when you have a storage tank facility, you've got to have these containment berms around it to protect from spills.
right.
Um, and if those berms are vegetated, then you've got to worry about cutting the grass, watering the grass, keeping that vegetation alive. Because if you don't, then there's a possibility that soil is going to slough off and those berms are going to erode over time. So we have
Right.
done a couple of projects in the Houston area where we just lined those berms with our thinnest material, screwed the panels together. And the first one that I went out and looked at was, I don't know, 2 or 3 years ago when I first started. We were installing one in Pasadena. So those are certainly in the Houston area for sure.
That's pretty that's interesting. So, with us being so petrochemical heavy, are you guys doing work on the industrial side? I feel like they would have different potential use cases for somewhat of that same sort of situation with like store, just trying to manage storage and leakage and different stuff that they don't want to have the
Yeah,
vegetation in the way.
we also did a project for Chevron last year in the Houston area where it was a drainage ditch application, just a
Mhm.
drainage ditch on the side of the road, which had
Yeah.
previously been, a pour-in-place concrete product. But after many
Oh, okay.
years, it had started to crack and they were losing water through it and causing erosive issues. So we went back
Oh,
and actually went over the existing concrete with the concrete
oh,
canvas.
interesting.
And because
Yeah,
it's so
yeah.
thin, you don't lose any water volume, any flow capacity. So in literally 3 hours, we had completely relined the ditch that was 100, 120 feet with the concrete canvas, and it was just like new again.
Wow, that's pretty interesting. that it's that thin, that it's not
Yes.
changing the numbers. It's not changing the math enough to where
Y-
it would affect,
Yeah,
you
the
know.
type 1 is 5 millimeters, so it's, a fifth of an
Oh.
inch. An inch is 25 millimeters, so yeah, it's not even a quarter of an inch thick.
How about I would put you on the spot a little bit. So, but I do it to everybody. Not really. It's I don't really. It's not like a crazy question, but I feel like we always learn just as much from our failures as our successes. So
Right?
would you say there's some thoughts on that? Like you have a failure you can point out. You don't have to say the company or the location, but like something where it happened. You like this happened, so then we had to do that. And now that's why we've got whatever.
Yeah, one of the failures that I have witnessed, and all the failures that I personally have seen have been caused by installation issues. We have
Of
no,
course, you
well,
know.
hold
No, I'm
on.
just playing. I'm playing. Like it's always the contractor's fault.
Well, no, it could also be a bad application, but we try to get out in front of those to make sure
Yeah,
that they
I'm
don't
just
use it. I mean,
picking.
we've had people wanting to use
Yeah,
it, in Cape Canaveral to connect the rocket waste. We're like, guys, it's concrete, but it's also very thin, and that stuff's
thin,
really hot,
pretty
so
thin.
that's probably
Uh,
not a good fit for this application.
that's funny.
Um, but we do have several, 20, 30 page installation guides for slope protection, for erosion control, containment, uh, wastewater and wastewater applications that go step by step, showing you how to install the material properly, how to anchor it, how to join the panels properly. There was a project up in Pennsylvania I went to a couple of years ago where it was a drainage swale on top of a hill where we had told the engineer that you typically would have an anchor trench on both edges of that trench, down about 6 inches. You would bury the material in the anchor trench, you would peg it down, backfill it with soil. And what that does is it keeps the water and the wind from getting up underneath the material and undermining it. Well, the engineer thought that he knew better and he didn't think that they needed anchor trenches, so they installed it without anchor trenches. And then, 9 months later, we were up there effecting some repairs on it because there were no anchor trenches to prevent the water that was running down that hill from going right up under the lip and washing it out. So we had to take a roll of material. Well, we shipped a roll of material up there. Didn't have to rip out the whole entire thing because it was the leading edge that had all the erosive problems, not the trailing edge. So the water was flowing down the hill and then washing this out, but then the other end was okay because the basin was catching the water and taking it down. So we did a patch repair on that. Took about a day and a half, 2 days to get that all patched up. That's the worst failure that I've seen. And again, it's because they didn't follow our installation recommendations. There was another
Right.
one in Seguin a couple of years ago that we did west of San Antonio. Oh, sorry, I guess east of San Antonio, where it was a project where it was erosion control, slope protection. There was a parking lot that drained into the river. They were having a lot of erosive problems. They cut a pretty good ditch into the soil, so they graded it, flattened it out, smoothed it out, and we're going to install the concrete canvas. And when they were doing the dirt work, I was there. I was explaining to them why we needed anchor trenches, and the supervisor said, "Oh, we don't need anchor trenches. We'll just peg it down." I said, "Well, if you're just going to peg it down the sides, you might as well go to Walmart and buy a tarp because water's going to get it right underneath that and wash it out."
Yeah, yeah.
And so he left, and the second guy in charge came up to me and said, "Yeah, we're going to do anchor trenches." I said, "Thanks." He goes, "That guy's retiring in December, so he doesn't care what happens as long as it lasts until January." So, I
Oh
mean,
my
he
gosh.
was going to be out of there in 3 or 4 months, so he didn't care. He just wanted to get it done fast. He didn't want to get it done right. So that's
Wow.
the biggest obstacle is just having people take the time and the
Steering.
effort to make sure that you do anchor it and install it correctly.
Sure, sure. So, let's go back to that. I'm thinking about that Chevron, that you said there was a ditch on the side, a road ditch. How much do you have some dollar? Like, give me an idea, estimates. Like, it seemed like that saved a lot of money.
Uh,
Like, because if you had to rip it all out, reform it, repour it,
oh, yeah.
it would have cost X. Where they came in with you guys and you were over to overlay it
We
for
typically
Y.
say $4 to $6 a square foot installed for those type of applications. If we're talking the thinnest material and you're just overlaying the existing substructure, there's not a lot of, prep work
Right.
involved.
Compared to what though? What would it have cost if they had to rip it out and redo it? I mean, I feel like that was a savings, right? There's
Oh yeah,
probably a sizable
pour
savings.
in place concrete is, 2 to 3 times what the cost of a concrete
Yeah.
canvas could be for a project for sure.
Yeah, so that's pretty cool. So, because I'm just thinking about like, municipalities are always hurting, and they've got to have degradation. Now, it's all we see in the news all the time is our infrastructure's falling apart, and so we keep kicking the can down the road. So I'm just thinking there's got to be a lot of municipalities that could use this solution to help them, you know, because it doesn't seem like it's a temporary solution. It seems like if they depending on this, I would assume depending on the current state of degradation of a certain channel, you could come in with your product and save them a ton of money, and it would last a long
Yeah,
time, 20
yeah,
plus
we
years.
expect a
Is that?
lifespan of up to 120 years for slope protection
Oh shit.
applications.
Okay.
Drainage applications can be more like 50 years, and that's going to
Wow.
depend again on the volume and the quality of what you got going through there and how often it goes through there. Um, yeah, it's a long life material. Talk about municipalities. A lot of the jobs that I did the first couple of years I was here were with local municipalities, and the one reason they like the stuff so much is because they can install it themselves. I could go out there for a day or two to get them started off on the right foot. I would go home and they would finish up the project. But there's no contractors to wait on. There's no rebar. There's no concrete forms. There's just not a lot of the detail, specialized labor kind of work that would be required if we're using a pour in place concrete.
Yep. There's another savings. I
Right.
mean, it all matters, like especially I've never talked to a municipality that said, that told me they were flush with cash.
Yeah, money's no issue, right?
Yeah. Like, oh yeah, we just do whatever we want over here. Like, no, I've never heard that ever. So, um, and maybe I'm just not wrapping my brain around it. I see remediation. So how does
Remediation
that
is what we're talking about, existing concrete that started to crack or seep, just going
remediate?
right over
Oh
that
yeah, yeah, yeah.
existing concrete,
I was
so
thinking,
remediating that
okay.
surface.
Yeah, 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 yeah. I got
We
you. I
did a
got you.
similar project in North Carolina last year under an overpass. Again,
Mhm.
you normally have the concrete underneath the overpass to protect from erosion. Well, they had a bunch of cracks and busted out spots in that poured in place concrete. So again, we were able to go over that existing concrete with the concrete canvas, prevent further erosion problems, and again, fix the problem in a couple of hours rather than a couple of days or a couple of weeks if they have had to bring in concrete to replace it.
Right. That's from the slope protection standpoint. What would you say a competing product would be? I mean, obviously, there's a lot of stabilization products or whatnot, but where do you guys, price wise and everything else, just as a whole, when somebody says X, you're like, no, no, we got it. We got it. We totally better check this out. This will help with, because I'm assuming you would even lean into like stream bank restoration and stuff like that, or
Done
no,
some of
like
that,
just
yeah, sure, sure.
or like shoreline. I mean, of course, I
Yes.
don't know much, but I'm just kind of trying to think how could I see this helping, and what product does it replace for those that may not
Our,
have a full grasp of it like myself.
yeah, in the irrigation segment, shotcrete is probably our biggest competitor, um, because
Oh,
you
that's
do
still
want
a
a concrete
but that's still a
surface,
concrete product. Okay,
right?
right, right.
Um, we've done a couple of studies, and obviously it depends on where you are and how long it is and how remote it is. But I mean, we're normally always at least a little bit cheaper than shotcrete, and we're always faster and easier than shotcrete. Um,
I
We're
got
the
you.
one way we differ from a lot of the traditional remediate our erosion control protections is we're not vegetated, so it works
Right.
great around berms in a in a storage in a state take storage farm because they don't want vegetated slopes. They don't want any sort of maintenance issues. They want to install something and forget about it. If you're doing a river or a stream, you may not want to have this hard armor concrete looking surface. You may want a vegetated turf reinforcement mat or something. So if you
Yep.
do need it to be vegetated, then we're not going to be the right product for that. It's got to be a place where you either don't want to mess with vegetation, or it could be a project where you can't get vegetation established. The year before last, we had a project for Georgia Power outside of Atlanta where they had a power plant and they had a very steep slope. It was about 60 feet from the bottom of the slope to the top of the slope. And it was about I guess it was it was almost a 1.5 to 1. I mean, it was a very steep slope. So they had tried unsuccessfully for a while to get vegetation established up on the slope, and they just couldn't do it. And there was all kinds of, pipes and pumps and everything between there and this 12-foot wall at the back. So they couldn't get any sort of big equipment up there because you had,
Oh,
a
neat.
4 or 5 foot
Okay.
catwalk up at the top where people could walk, and that was it.
Mhm.
So they reached out to us. We took the concrete canvas out there. They actually had their preferred contractor that they use for maintenance issues around that power plant there. So they actually did the installation for them. So what we had to do was, again, we had a 12-foot wall at the very top of this very steep slope. There was a Dollar General in the parking lot behind that 12-foot wall. So we deployed the material in the Dollar General behind the parking lot, cut pieces that were, 50 foot long, craned them over this 12-foot wall onto the slope. And then these two guys that were, tethered off to the
Yeah.
wall because it was so steep for safety issues, they sort of, rappelled down as they were deploying the
Wow.
concrete canvas. So that project took more like a week and a half, but it was because of the logistics and the safety issues and the steepness of the slope. But for the first time in years, they've now got an erosion control system on a slope that otherwise there was really not much you could do just because of the tight spaces back there they were working with.
And then do they have to deal with the sheet flow off of that after the fact? Does that come into the play? Do you guys discuss that with them, or do you have solutions to go along with concrete canvas to help them, or no?
They do, but in this case, it was sloping down into just this concrete basin where all these pumps and well concrete and broken up rock. So there was no erosive problems at the bottom of that. So
Oh,
the
I got
water was just flowing down anyway. I mean, whether you have
you.
a vegetative solution or not, you've got a defined area of slope, and pretty much
Sure.
after that soil gets saturated, the same amount of water is going to run down, whether it's soil or concrete canvas. So
Right.
they had
Right.
already taken care of those issues.
And I would assume, I mean, you guys are already working with so many different variables and keeping this thing so thin that everything that you guys do is from from a pervious standpoint. There's not a version of this that is, you know, um, permeable, right? Like
No.
there's not,
Now
yeah,
you
that would
can
be
control the
one extra, yeah, that would be crazy. So I thought I'd ask anyways.
now you can sort of control the permeability by how you join the panels. Um,
Oh, okay, yeah, that makes sense. Yeah.
Most of the time, if it's a drainage canal, drainage ditch, an application where there's water in it during a storm event, but it's not necessarily designed to contain water over a period of time, we can just screw those panels together with stainless steel screws on typically 4-inch centers. So that's not going to be an impermeable joint, but you're going to shingle it in the flow of water so that water is going to flow over that joint and not back up into it. That's also the recommended joint if you have areas where you've got a very high water table and you don't want that hydrostatic pressure to lift it from the bottom of it and potentially damage the material. Um, so screw joint is far and away the most common that's used. It's used for slope protection because with slope protection, you've just got sheeting going, parallel to the seams, not over the seams.
Hmm.
So with slope protection, you can just screw the panels together. With drainage ditches where you got water flowing during storm events, you can just screw the panels together. If you need to have a lower permeability option, then those seams can be augmented with sealant prior to screwing, or we can also thermally bond those with just a hot air, Leister hot welder to melt the bottom membrane of the top to the top geotextile of the bottom. The permeability of that joint's been tested to about 5 to the -8 centimeters per second. So not zero, not a welded geomembrane, but still much, much lower than if, even concrete maybe. Um,
I got you.
we did a project in California a couple of years ago where they had an existing irrigation canal, so it was always holding water during farming season. The
Okay.
existing concrete was 20, 25 years old. There were chunks of it that were missing. It was cracked. They were losing a lot of water through seepage because the concrete was such in poor condition. And especially in California, water is expensive because there's not a lot of it, especially when you're farming out in the desert. So we lined this canal was a quarter mile long. We started on Monday. We finished up on Thursday afternoon. So before we got to the site, they had taken out all the old busted concrete, reprofiled it, dug the anchor trenches. So when we got there, we were just installing the concrete canvas. Again, it was the personnel from the irrigation district that were doing the work. We went out there for a couple of days again to show them how to do thermally bonding, to show them how to do the screws and to peg in the anchor trenches, and just help them with the process. We went home and they finished it up on again Thursday afternoon. So 3.5 days to line a quarter-mile canal. Um, Once we were done, they let it cure for a couple of days. They did a seepage test and determined that relining the canal had reduced the seepage by more than 96% as compared to what
Right.
it was, prior. So
Yeah,
again, not
yeah.
zero, but if you can get more than 96% seepage reduction, that's pretty good.
Yeah, and I mean, and I don't know how my listeners will feel, or, the pod. They're good to me. They don't point out how ignorant I am, so that's great. They just enjoy it and move on. But I'm really this has been great. This is cool. I like stuff like this that I just didn't even know. I mean, there's just it's a great solution, especially like in that example you were given where it was just, you weren't going to be able to get anything else in there, and to be able to provide them with that solution, that this is it. This is how you're going to do it. Otherwise, you're going to be stuck with that erosion. But you know, and I've been looking. I'm not looking at you. I'm actually looking over here at the website and some different stuff. There's some great photos on here. Everybody should go check it out. Concretecanvas.com is what I'm on right now. Yeah, concretecanvas.com. If you got questions, there's an info at concretecanvas.us, or Nathan, we can put all of your contact information in the show notes so people can reach out if they've got technical questions for you. Kind of to wrap things up, where do you see the most success? You guys, like you said, you've 15 years, I guess, but then with the new standards, like about 4 years, where are you finding the most success, and in what application right now in the country?
It depends on, it's really a geographic location. For example, in Japan, we're an international company. We sell to just about every country in the world. In Japan, our single biggest application is around road signs, highway signs for weed suppression. They've got a couple of guys
Oh,
in the truck with the smaller batch rolls. And they'll take a
uh-huh.
couple of those out and put it around a road sign or a street sign or a directional sign. So after they
Wow.
install the concrete canvas around that road sign, then there's no more weed eating, there's no herbicide, there's no vines going up the poles. They can just mow up to the edge of that concrete canvas, and it cuts down significantly on their maintenance cost of maintaining the roadways. Um, on the West Coast, irrigation is big. We did a 5 or 6 demonstration projects out there with some different irrigation districts. In Houston, petrochemical is big. East Coast, we're getting into the landfill market a little bit more. We've done a couple of berms in New Mexico. It really just depends on where you are geographically. In Florida, they've got a lot of drainage issues. We did a project 2 years ago in a subdivision down there where the problem was it was a residential area. It's Florida. Every time it rains, these dishes would silt up. So once it silts up enough, they've got to come out there with an excavator. They got to reprofile it. They've got to put that dirt into a truck and take it somewhere to get rid of the dirt. So we were able to go in there and install concrete canvas. And this was in December of 23. We did this, I think. Uh, and it was only like a 140-foot long ditch. It took us, we started at 8:30 and we were done in time for lunch. So 3.5
Oh, wow.
hours, and we fixed their problem. In fact, they were so happy with it that this past year they did 3 or 4 more ditches in that same exact area
Oh, yeah, of
because they had,
course.
a year or two under the belt and saw that it worked well and were happy with it and went out there and did some more of it. So I can't really tell you what the number one application is. It really
Yeah.
depends on where you are
Yeah.
geographically.
No, that's cool. Well, what did I miss? What did we miss? What is there any other thoughts that you have about projects, applications, just any stories that you want to share before we sign off here?
While it is concrete, it is thin, so it's not designed for, roadways, not designed for jogging paths, that kind of stuff. We get a lot of people that are curious about
Oh, yeah.
using it in those type of
Weight.
applications, and it's
Yeah. Yeah, it
Um,
can't take a lot of weight. Like no, not a lot of heavy traffic, right? Just
it could if it were prepared properly, but it's going to
mm,
cost a lot of
mm,
money to get that subgrade prepared properly. We actually put some in a feedlot in Wales, where we had a 20 by 20 foot square. We prep the soil. We use gravel and geotextile and everything to reinforce it underneath it. So the soil was already as hard as a rock. Put the GCCM on top of it, and 100 head of cattle ran over it twice a day for 6 months, and it was still doing pretty good. So it's possible to do that, but you've got to have everything just right, and you've got to make sure the subgrade is just right. You can't
right,
have any sort
right,
of differential displacement, because that's gonna, once you have any sort of void space or sinkage in the soil, then that's going to give you the potential for damage or cracking. So it can't be used for
right.
that. Another advantage of it over a lot of other conventional methods is it can actually be deployed in the water. If you've got a ditch with a couple of inches of water in it, you wouldn't be able to pour concrete in there or spray shotcrete, but you can deploy the GCCM through those couple of inches of water. Pop in your screws, and it'll harden up the same if it's underwater for the first 24 hours as it would if you sprayed it with the hose and waited 24 hours. So you can't put too much water on this stuff. It's been used as boat ramp extensions and installed under the water and stays under the water. So that's another advantage over some of the other materials.
It stayed under. It just stayed forever submerged.
Yeah, and in
So
fact, the way that we do our yeah
it'll
the
cure. It'll cure submerged.
yeah
Wow.
the way ASTM requires you to do your testing is you take a specimen of it, you submerge it
Uh-huh.
in a bucket of water for 24 hours, then you take it out, pat it dry, and cut your samples into your testing. Because with concrete, that's going to be the worst case scenario, is if you're completely submerged for the first 24 hours. So yeah,
Wow.
that's the way the testing is done, is worst case.
Well, I mean, I know out of all this craziness with the TikTok video and people reaching out that you kind of got thrown into the mix here and we got to get together, but I'm so glad we did, Nathan. It was nice meeting you. If you have any other thoughts, fantastic. Otherwise, I think we've provided some good basic information on what you guys do about the product. You answered a lot of my questions, which is fantastic. And then of course my wife is a civil engineer and loves concrete, and she does our show notes for the podcast. So she's gonna be pumped to listen to this episode. I promise you that. She may want to reach out with questions. I don't know, but yeah. If you don't have any final thoughts, then that's the pod.
Sounds good. I
Thank you so
appreciate
much.
for having me.
Thanks a lot.